All right, let's talk about extensive form games. So last time when in the previous video when I introduced game theory, we said there's two types of non-cooperative games, extensive form and normal form. And the extensive form game, we want to think of an example of an extensive form game. And the best way, you think of extensive form game as kind of like a tree diagram. And so the example we're going to use here is we're going to think about chess. Okay? Modeling the game of chess. This is game theory, so let's model this out. So the game of chess has got some fairly concrete rules. Here's the first player. By convention, white plays first on a chessboard. Now, we're building a tree diagram. How many different possible moves does white have? You stop and think about it. You say, well, let's see. How many different possible moves does white have? Well, that's the number of branches of the tree that we have to actually write out. What are the possible moves that white has? It turns out there are 20 different moves for the opening move of a chess game. Think about it. You have 8 pawns in a row. You can move each one of those 8 pawns either 1 piece forward or 2 hops forward. So there's 16 possible moves with a pawn. 8 pawns. Each pawn has 2 possible positions they can move to. Plus you have king's knight can go out right, king's knight can go out left, queen's knight can go out right, queen's knight can go out left. So there are 4 possible moves from the knights, and that means that white has 20 possible positions of the board after white's first move. Each one of these nodes, and I'm not going to draw all 20 of them. Okay, there's 20 after just one move. Now black's turn. Now black comes in, and black has how many possible moves for black on this to open the game? Well, you can figure that out. It's still the same 20. Okay, the game is really in an infancy, and black can also move any one of the pawns out 1 space or 2 spaces. That's 16 possible outcomes for the pawn. Plus, black could move king's knight out right or left, queen's knight out right or left. And so for each one of the possible positions of the board, when white got done, black has 20 possible outcomes that it can put there. So I'm not going to put them all down there, but you can see on each one of these nodes, black now has 20 possible that black could choose. And now it's white's turn again. And now, how many of them are there? Well, now there's 400, right? Because there were 20 nodes, 20 possible outcomes of the board after white's first move. Now black has 20 possible moves that it could make off of any of those initial moves from white. And so the 20 times 20 is there's 400 nodes already, just after one play. White plays and then black plays, we've already got 400 possible branches of the tree. Now let's go back to what white has. Well, white has all these nodes, 400 of them, and one of them is where the game board is, and from that one, white has how many moves? Well, again, white can move some pawns out more or less, but maybe the first move, the white moved a pawn out so that the queen can come out 1, or queen can 2, or queen because at an angle 3, queen at 4. So some of these nodes, white may have as many as 25, 26 moves. Some of them less if they hadn't broken any of the moves out in front of the queens or the bishops or the rooks. It might be a situation where they have less to know, but you can see what's happening. These nodes are exploding exponentially. So you only have to be a few moves down, and you can see these the large number of outcomes of this possible game. If you've ever played these computer games on your computer, when you play these computer games on your computer, at least when I do, if you play it like level 1. Play at level 1, I can win all the time. Okay, games are real fast. Okay, if you set it up to say level 2, the game's a little bit slower, I can still win. Level 3, I can hold my own, but by the time you move to level 4, the computer's a little bit slower. In fact, sometimes noticeably slower, and I never win. Okay, the computer beats me all the time in these games. See, what's happening is when you're setting a different level when you're playing in these games, you're telling the computer how many branches the computer can go down and evaluate the outcomes of the game to say which one of those is best for me. I can see if the computer could see 3 moves ahead, the computer could see, millions more outcomes. But the computer, of course, that's what they're good at, is evaluating millions of things in nanoseconds. All the clicks in the CPU. And so if you tell the computer that it has a lot of time, it can go a long way down this game. It can think way down here and maybe be, 5, 6 moves ahead of you if you give it all that time. That's, in competitive matches, they can't do that because there's time limits on that. It's really hard. There was a competition after the mathematicians first talked about this extensive form of game of chess. People wondered, is there a finite number of possible moves? Is there a finite number of board positions? Or is it just too big? And it turns out they put a prize up. The prize money was a lot of money back in those days. We're talking about in the 50s and 60s, it was like $100,000, which was, several times more than what faculty salaries were in those days. So it was a pretty big prize. And in fact, it was proven that there is a finite number. There's a finite number of moves in a chess game. Now, once you think about that, there's a finite number of moves, then presumably we can always find to win. If there's a finite number, let's just evaluate them all. Well, it turns out it's a finite number, but it's so big that even if you took the fastest supercomputers that we know right now, it would take them, decades to figure this process out. So it's a finite number, but it's a huge finite number. So the point is, even though if the computer was so fast they could do it all, then the computer would never lose. IBM has this computer called Deep Blue. Deep Blue is a computer that has been able to beat grandmasters in chess. Deep Blue is a computer that only does chess. That's all it does. And Deep Blue does this type of chess. It just races through the nodes. It races ahead and again, by the time you get in the middle of a chess game, the number of possible nodes to look at is huge. Okay, it was estimated that probably the best grand champion ever in terms of chess skills and ability was this guy named Bobby Fischer, and people claimed that Bobby Fischer could see 7 moves ahead, which is more than anybody ever. Deep Blue cannot see 7 moves ahead. Right? So how could Bobby Fischer be better than the Deep Blue? Well, the difference is Deep Blue is a pure number cruncher. Deep Blue just is a node searcher. Okay, Bobby Fischer did something called pattern recognition, where Bobby Fischer would just throw out vast parts of the entire thing. Bobby Fischer would say, this stuff is all irrelevant. I'm only going to look at the nodes that come down from here. So Bobby Fischer, through the human brain, could basically recognize that some of these things are just dumb, and I don't need to waste time evaluating all those nodes. Computers don't have that right now yet. Artificial intelligence, AI, is working hard on trying to incorporate pattern recognition into Deep Blues, so it's not just a pure, let me solve all these nodes and go down to the next level. Let me solve all these nodes, which will make Deep Blue even farther. Okay, so that's an example of a game in extensive form. Let's think about this with respect to economics. Thanks.